Hi everyone, and welcome. This is the final CAS Inspire session of the term, as the half term, as it were. And we've got three special guests for you today. We've got Sarah Taylor, we've got Ben Davies, and we've also got Matt Warren. The topic for today is CAS Inspire Ensuring Progression in Scratch. So this is going to be really exciting. I know there's lots of information about how you can progress your learners through block-based coding. So I'm really excited about listening to this one. My name is Peter Marshman. I'm one of the CAS outreach managers, and I'm also joined as well by Leah, who's in the background, and she's doing all the wonderful bits to make us be here right now. And she'll be controlling and looking at all the questions alongside with myself. So if you've got any questions, do drop them in the question section. And if there's any links or anything, I'll be popping them in the chat as we go along. So what I want to do is just introduce our three super special guests today. So first of all, we've got Matt, who is, there's a lot of information here. Matt is a very, very busy person. He is a master teacher. He's a community leader. He's a senior leader, head of computing and digital learning at RGS, the Grange in Worcester. If you want to get hold of Matt on Twitter, it is at Matt Warren, and I'll drop these in the chat in a moment once everyone gets started. We've also got Ben with us today. So Ben's an upper Key Stage 2 teacher with over 20 years experience in the classroom. He's a specialist leader in education, a STEM associate facilitator, a CAS community leader, a Barefoot ambassador. There's a lot of commas in here. I should have worked this one out. He's a resource developer and subject leader. He's also very, very passionate about promoting learning strategies to allow children to deepen and apply their knowledge in computing. And I will definitely need to put Ben's Twitter handle in the chat, because it's Ben Davies, but with the E's as threes. So you can work that one out, or you can wait and I'll drop those ones in. We've also, last but no means least, we've also got Sarah. She is the lead of the NCC Odyssey Computing Hub, which I hear is absolutely brilliant, and runs the Forest of Dean CAS community based in Gloucestershire. And she has taught computing at school for over 25 years to both Key Stage 1 and Key Stage 2. Most of her career, she's been a subject lead in computing, and she's worked with primary schools as a consultant as well for Gloucestershire City County Council. And she loves working with colleagues to develop their enthusiasm for the subject. And you can kind of get hold of Sarah through a hub, which is at Computing Hub OTS, which again, I will put in the chat. So that is definitely more than enough from me. So what I'm going to do now is I'm going to hand straight over to Matt, who's going to start us off on this journey with Scratch today. Off you go, Matt.
Lovely, thank you very much, Pete. It's a pleasure to join you this afternoon, this blustery afternoon in Worcester. So hopefully I'm going to share some top tips for sort of tools that I use in the classroom for evaluating, because I suppose we're looking sort of progress in mind. If we can evaluate and we can do this really well, we have a good idea where our students are and how we can move them forward. So here we go. Tip one. All right, I'm going to go through these in order. Hopefully, there's a little bit of video in the background. If you're listening to this through the podcast medium, I'll try and explain what's going on. Number one, these are really nice tips that are free, that are simple, that I think you can just get hold of and use straight away. Talk through your code. So, as you're working at through projects where pupils are actually developing their skills, if you hold down Control and click on any aspect of a block of code, what you can do is to annotate, so you can start to add meaning. Now, this is great from a valuation point of view. You can either use this, I say, in two ways really. Prim, so where you're going to give them the whole project to start at the start and predict and make predictions, explaining what the loops are actually doing, what aspects of the code are actually doing. This is a really, really lovely starting point. Or you can do this at some point throughout a project when pupils are, maybe they're stuck, maybe they're sort of in the middle of a battle to try and work out where they're going next with their code. Let's just stop, let's take a break, and let's work out what you've accomplished so far. Especially works well with pupils when they get in a bit of a tangle and they've got code everywhere. Just stop, explain what you've done, and let's see that your actual reasoning, your logic matches your intentions. So tip one, talk through your code, hold down Control, add some annotations. Okay, I will quickly move on to the next one. Okay, so that's going to look at sort of misconceptions assist with the logical thought, efficiency as well. Can we perform something a little bit better? Can we use less code? And we got two, I often find this with pupils, they'll have more than one block of code that's doing the same thing. So we can get them to just stop, reflect and think about it. We can hopefully debug and make their code a little bit more efficient as well. And also understanding. So next one, I think this is probably the simplest. I'm in a pretty fortunate position in the sense that we do have one-to-one iPad, but I've done this with one iPad with 31 pupils, and it works equally as well. So my pupils will get to a point in the session, and it might be near the end, and I'll say, right, stop. I want you now to just film your project, and I want you to explain to me exactly what's going on, what you've managed to code successfully, what is working really well for you. But also, this is where the learning, this is the crux of the lesson. What is not going well for you? Where are you going to take your learning forward? And I find by just giving them these moments to just stop and reflect, it can be, as I said, any point in the lesson. If you're working with one device, maybe set it up, cheap tripod in the corner of the room. It's almost like the sort of the big brother diary room. Send the pupils over, maybe just have a little prompt card up there with 3 or 4 simple questions. As I said, keep this really simple, and it gives you a really nice grasp into what the pupils actually understand by what they've produced. I think if we can get inside the pupils' heads, it's going to give us a really nice understanding of, you know, these are the questions I would often use. What's going well? What's challenged you? What's the plan for the next session? I'm a computing specialist, and I know teachers out there will probably teach maybe about an hour a week, but what's going to happen in that week or that time lag before the next session? But if we can get the pupils to preempt that, to plan, to look ahead, then it's going to close that feedback loop ever so slightly, where teachers can intercept and give some little promotion of tips and ways they're going to go forward. And also, how did you overcome difficulties? For me, this brings out, you know, the best part of the subject. Really, it's not about me having the answers. It's about pushing the, you know, the pupils to work together, to collaborate, to ask 3 before me, to really look at different ways of engineering the classroom where it's not the teacher has all the answers. Okay, so that is lights, camera, action. Again, really nice and easy to implement. This is something I've been doing recently, which has massive benefits. Again, it's based in Scratch, alpha and beta testing. Again, this gives the pupils a chance, a glimpse really into how the big bad world of programming actually works. So we envisage an idea, pupils plan it. In this instance, we got some year 6 doing a project where they've made a clock. So I'll often get sort of that alpha stage will be where I'll get them to invite a few of their friends over to test their project and see what they can do to potentially improve it. Looking at, you know, are there bugs in the code? Is there something? Because it's often their friends will try and break something or find something that will, it doesn't work. You know, it's going to be a nice open conversation. The beta testing is going to look a little bit like this. So we get the pupils to actually share their project on Scratch using that massive orange button at the top to share. I always use the Scratch classroom, so I will have my cohort of year 6 will be as a class in a class group with me. Once they've shared it, we'll make a little studio and they'll add their work to the studio. And then they absolutely love this. They're working on this today for 40 minutes, testing each other's projects. And this is, you've got to get this bit right though. What do you like about the project? We've got to move away from this project is cool. Think about this. You know, I often say, what's cool about the project? You know, what's good about the project? We've got to be specific, because at the end of the day, what we're trying to achieve here is meaningful feedback. Okay, so let's look at these 2 examples. I like your project. The hands are accurate. Okay, I like the hide and show button. You could make the actual reset button and the stop button. So good. So what he's given there is what he likes about it. So it's that nice positive buzz about the project, but what he could do next. The next stage from alpha and beta is that the pupils will have time to review all these comments that have come in, to actually implement them, to actually put them into practice. And then it goes on to sort of, it leads nicely into sort of beyond alpha and beta. So what I feel this does is it gives testing for a reason. I'm only an aspect of this. This now builds it into a bigger picture. You know, you're not producing this work for me. This is going to be for, you know, people actually playing your game, your friends, beyond your friends. Okay, builds in their digital literacy skills. Their feedback actually sticks onto that project. They've got to understand that. And also a little bit more emphasis on that debugging as individuals. My final point there is we get all the pupils to launch a website in year 5 and 6. Primarily designed to kind of host all their computing work. So an example here, you can see Scratch work. So beyond alpha beta testing, this is where we'd get their work to come to life, and we'd share it on their website where they can share it with friends, with family, and people from the outside world can access their work, and they can really get a handle on digital skills whilst being very comfortable with the coding aspect. So it brings those two worlds together. So I've called that one the great beyond, beyond sort of alpha and beta testing. So in a nutshell, there's my points. It gives global audiences for their work, not just for the teacher. So therefore, there's a little bit more emphasis on the quality, understanding, and progression. The digital literacy skills go well beyond this. It's a really lovely way to get this into coding. That digital awareness, who can see my work, that real pride because it's going online and it now has a purpose. So there's some simple tips from me about how I feel you can use some simple tips to start evaluating work in Scratch. And on that note, I will pass on, and I cannot wait to hear some tips from Ben and Sarah, who are also experts in the field. So I look forward to your presentations.
Oh, thank you very much, Matt. I thought that digital portfolio idea at the end is absolute blinder. Yeah, what really came out of that was you saying that it's purposeful, that last bit, and having that environment to do it. It's a really good idea. Right, thank you very much. So hopefully hopefully I can find my screen that I want to share, which I can't at the moment. There we go. So I'm going to talk about how we get around to evaluating and what we might want to evaluate when we're looking at using Scratch across the school. So the first thing to think about really is that Scratch is the environment, it's the tools by which we are going to assess the progress that children are making through the computer science aspect of the primary computing curriculum. So the things that need to be in place to getting the conditions right. Have we got a sequenced and progressive curriculum in there? Have you identified the key knowledge, skills, and understanding? And are they being developed? Are they being secured? Are there opportunities to deepen them as well? Is the curriculum organized so the key learning is revisited and built upon? Are children having the opportunities to apply these knowledge, skills, and understanding? And are we concentrating on the application and not just the output? So you can get some stuff with Scratch to look rather wonderful, but are you looking at the wonder and the awe of, wow, a child has made this? Or are we thinking about what's gone into making it and how that's been applied? So going on from that, what I've tended to do, or and this is something that you might want to do, is to think about unpacking the curriculum. So by that, what I mean is thinking about those individual concepts, the sequence, selection, repetition, and pulling them apart and actually saying, well, it's not just one thing. We can make progression within that. And the benefits of that, well, one, that those smaller steps allow for a deeper understanding, and it allows us to evaluate where in that progression for that concept a child might be. So I think using this sort of approach will make your evaluation, make your assessment judgments more accurate. So just want to sort of share with you what this could look like. So this is how we do it here, how it's been done, and how we introduce our progression through Scratch. But it's really, it's a sort of conversation to be had with school, with teachers. So if we start by having a look at sequence, and how we would introduce sequence is just by looking at a very linear sequence where children, you can see starting with the left of the page, we have a program where children are looking at really animation, and they're using blocks that have delays built into them. So they're getting the appreciation that hello is going to stay on the screen for 1 second. And they might be changing the number of seconds depending on how long or the volume that's being put in the speech bubble. With that, then we'd be moving the children on to thinking about the need for those wait blocks if they are, as this instance shows, a sort of sequence in a dance, and you want those blocks in just so there's enough time between each movement for it to register. Then we would move on to having the sequence between 2 scripts in a program. So starting off with a simple joke with one responding to another. And then finally, this is where you might want to move on to introducing use of broadcasts to make it, so we're refining this use of 2 scripts, making it more succinct, using the broadcast and wait buttons. Now, I wouldn't say this is a unit plan. This is how sequencing can look and where we would introduce sequencing and where a pupil might end up if they're on that continuum. So repetition in a similar way. We introduce it in here. You might recognize some of this. This is following on from the previous slide, the dance movement. So in that, we're exploring it by saying, well, what happens if we use a count control loop and we stick 3 in here? Okay, so that's introducing, tinkering, and exploring. Then we might move on to a more refined use of it. So these next 2 examples have been modified from the Barefoot Primary Prim resources, which they modified crystal flowers to make with a prim output on it. But we'd be looking at children's their purposeful use of count control loops. So here, knowing that they're making a square, so they want this instruction repeated 4 times. In this one, we've got a nested loop, so we've got the square being reproduced again, but we've got this relationship between the 10 and the 36 to make 360 to make a circular pattern with the squares. Moving on then to introducing selection, and for me, that's where I bring in in school. That's where we bring in repetition, because that's where I think that's where you can sort of talk about why you need to use that forever loop, so that the conditions are constantly being checked. And through that, then we start off with if statements, then we move into simple, and again, keeping it simple so they can focus on the concept, but just, a character saying something, responding to an input. Then we might move on to, so this example here is looking at a maze game, and if we're looking at the color red, so the color red is the color of the outlines of the maze. So if they touch that, and then it says mouse pointer there, but that should be the name of a sprite, and there's a sprite at the end of the game. Normally we would set it to something like winner, so that the children know when they're looking for that. So, and again, using the forever loop. And then we might move on to something, so this is taken from the Year 5, the NCC Selection 2 program in B, where there's quiz questions, and then you're pointing out to people they don't need to use forever because they're using the question and this wait command. So the computer is waiting for the response so it doesn't move on. And then finally, we might be looking at variables and how we introduce those. So building on selection and introducing the value of a sensor that's already being used through Scratch, so it's been able to use able to monitor the loudness in the classroom and setting backdrops to a different color if the class are being too noisy, if the red screen comes on. Then we can build on the quiz that we've done and get pupils to thinking about, well, actually, if I want to put a scoring system into my quiz, well, I'll need to initialize, I'll need to change the values. Then we could move on to actually, at the end of the quiz, could I then use their score to trigger something? So we've got well done if the score is greater than 3, practice and try again if it's less than 3. And then the final that I would use with variables is the idea of a sort of an activity selector, or the magic 8-ball sort of thing, where you generate a random number. On this example, we've got numbers picked between 1 and 3, and the backdrop changes to swimming, cinema, or bowling, depending on which number it generates. So Right. Then with that, so if you're moving through that, what things can we do to sort of see how children are doing to make sure that we assess? So one thing to think about is the use of unplugged resources. And yes, sort of a note about making sure that we're thinking about the semantic wave, that we are going from the abstract into the concrete to simplify it, but making sure that we're taking it back to the abstract so that the concept moves from one to the other and doesn't just stick with the activity. But I also find that using an unplugged resource is also good for recapping on previous understanding, particularly the understanding that we're going to be building upon in that part of our progression. So have children remembered sequence? Are they aware of account control loops? These are the things that I need to be using in them. And I really like to use the context of the program for my unplugged activity. So if we're doing a quiz, then the unplugged activity will mimic the quiz, and I'll be looking to pull out those key aspects and certainly addressing any misconceptions in that. Yes, then to talk on, so similar to what Matt was saying. So one of the problems that I find with just looking at a program is, what am I actually assessing, and how do I know we're 1 to 2 with our devices? So how do I know the split? How do I know who's made those decisions? So building in ideas where children just respond to questions. So I'm getting them to copy their ideas in, but I'm also getting them to answer these questions. So then these examples explain to me how they've used selection and repetition. And other things, activities that I like to use are code reading activities, using this wonderful website here called Scratch Blocks, where you can just type it gives you an explanation. You type your code in and you can get sort of good resolution Scratch blocks that you can download, wonderful for displays in the classroom. But just doing things like giving children this and asking them to create a storyboard that shows the animation here. So you can see they're just basic, but they're thinking about the repetition because they're ticking to see what's in the loop. Giving them these and asking them to sort of the differences between the programs and which one are examples of selection, which ones will produce an output and what the condition needs to be, and also sort of things that you might do in other lesson areas. So giving them 3 codes and saying, right, this statement is true for which of them, so which one includes a variable, which one sets a variable to the value of 2, and so those things where we can get that information. You can do these on computer, you can do these on paper, but you get to see what children are thinking, I think, and you get to appreciate the decisions they are making and their understanding of the concepts, the key concepts that we are teaching them. And I think, if memory serves correct, that's my last slide. So with that, I shall pass you over to Sarah. Thank you very much.
Okay, is my screen showing? Can you see the presentation? Yeah. Okay, I'm afraid it's on a different screen to the one that I'm looking at, so I'm going to turn myself off so you can't see me looking to one side. Thank you very much. Thank you for Ben and Matt. Those are brilliant presentations. I feel quite daunted now doing my bit. Thanks for that. So my remit really was to have a look at some practical tips to kind of differentiate and make sure that all learners progress within the lessons. So I thought I'd just go through some of the kind of activities that I used to use with children in order to make sure that they did all have a go at the lessons that we were doing. And the first thing that I would really recommend, I'm sure everybody is looking at it, but if you haven't come across it, the pedagogy principles on the Teach Computing website, I think they provide a fantastic toolbox of strategies for teaching computing and for making it accessible for all. And it's worth a read and then a reread and not just going through it once, but having a good old look again and again, because there is so much packed in there. On the actual web page, they've got further information for most of the principles, and they take the form of kind of podcasts or quick reads. So if you haven't gone recently to have a look, do go back and have a squiz at that, because there are lots of things there that are really helpful. One of the principles is around structuring lessons. And it talks about using supportive frameworks to enable scaffolding to be built in throughout a lesson or a unit of work. And I know that Matt and Ben have sort of both talked about the PRIM, and that's one of the supportive frameworks that they talk about, which I think is an absolute game changer in terms of organising your lesson. It's brilliant. Scratch is really open-ended. You can do some really sophisticated things with it. So using things like PRIM and use, modify, create can help you to make sure that all learners are able to succeed in a lesson. One of my favourite go-tos with regards to structuring a lesson, which focuses on a specific aspect of programming, is the use of Parsons problems. And this provides the learners with all the blocks of codes that they'll need, that they then have to put together in the correct sequence to make the program run successfully. So you can use comments on the event blocks at the top to provide the kind of algorithm and provide a bit of additional support. And then the fact that the learner has the blocks of code that they've already provided, it means that they can focus on implementing the algorithm as code. So they're thinking about the sequence of the blocks, using logical thinking, debugging, and then they can do all that without having to also work out which blocks they need to use. So this type of activity sort of reduces cognitive load while still allowing the learner to develop all those key programming skills. So the example that you can see on the screen is a program that I used to use with the children, and it's focusing on loops, and specifically repeat until or condition controlled loops, which are always a bit tricky to help children to understand. And the game involves frogs moving around the screen randomly, and the player has to click on the even frogs. And every time they manage to do this, the even frog turns into a splat, and the score kind of increases by 1. So if they click on an odd frog, nothing happens, but if they click on an even frog, then they actually sort of get a better score. So the repeat until block is used with the glide 1 second to random position block. And so when those two are used together, the repeat until the score reaches 4, move around the screen randomly, means that the 4 relates to the total number of even frogs. So when they've achieved that score, they've kind of achieved the maximum, and everything needs to stop at that point because they've won. So not the most exciting of games, but it was the fact that the frogs splatted, I think, added a bit of pleasure for the children. So in terms of what else you can do with something like Parsons problems for that, so it's the same task, and depending on the needs of the learners in the class as to how you structure your kind of Parsons problem type activity, you might want to increase the level of challenge by adding in additional blocks, so they've got the ones that they need to use, but they've also got some extra ones that they've got to select from. And this time the learner's got all the blocks for the program, but they have to select the correct loop to make the program work successfully. So if you're focusing on loops and the repeat until or the condition controlled loop, then they've got to make the best selection from the ones that are available. So that just adds in that sort of extra bit of challenge. And then in this example, so this is moving on again, making it a bit more challenging. The learner's been given the task of creating the program with the blocks provided, but needs to include an additional block. They're allowed 1 extra block. So this is going to require them to identify that the repeat until block would be needed in order to complete the program. It is possible to create a working program using the forever block, but this would need more than 1 block to be added. So by limiting the number of additional blocks they need to 1, you're almost forcing them to identify that they need to use the condition controlled loop rather than the sort of more familiar and comfortable forever loop. So then moving on to a little bit more challenge. This is a much more open approach. So again, same task, but having been given the event blocks and the algorithm in the note, the learners then got to identify all the code blocks that would be needed for the program, and that includes the loop. So this would also be quite a good activity to see if the learner uses the condition controlled loop or defaults to the forever loop. And this is by far the most challenging approach to the activity. So you can see with a single activity, you can have lots of different approaches that kind of vary the level of challenge. And then, so this one is spotting bugs. Yep, so spotting bugs. And this might be a good way of getting learners to focus on the use of loops. In this example, the frog would move once and would then stop, as there's no forever loop. So they would need to understand the fact that the forever loop would check to make sure the condition has been met multiple times. But then you could also change the if-then selection block to repeat until, and that would also work. And that it would be interesting then to see if they recognise that they could use that condition loop, condition controlled loop. So moving on from that, the use, modify, create type activity that you can use to structure your lessons, modifying the game. So taking the same example, you can talk to children about modifying the game to make it more engaging for the audience. And on the screen are some examples for how they could do that to make it more challenging. So that's how they're going to make it more engaging, by making it more challenging. It would involve lots of programming and computational thinking skills, and the list of possible modifications get more challenging the further down the list you go. So for example, the frogs moving faster would involve reducing the number of seconds in the glide 2 block. But a common misconception with learners, I've found anyway when I've been doing this kind of thing, is that they think that in order to make the frogs move faster, you have to increase the number of seconds. They're thinking if the number gets bigger, then it gets faster. The frogs could be smaller. This would involve going into the sprite properties and changing the percentage of the size. The learner would need to decide on a percentage that increased the level of challenge, but didn't make the game frustratingly impossible. Adding more frogs, it's likely, when I've done this kind of thing with children, it's likely that they start by creating a frog and then programming it. And there's a really important lesson around working efficiently and using logical thinking here, because it would be much more efficient to duplicate the odd and even frogs and then change the original costume to different odd and even numbers. Adding more objects to avoid would involve adding different sprites, which would need to move around the screen randomly. And then if they were clicked or touched, would end the game. So you can do it so that if it's clicked, then end all. So that's quite simple programming. And you could make it more challenging by explaining that they've got to make it so that if the sprite was touched by the mouse pointer, then stop all. And this would require a forever loop around the if-then selection block. Adding objects that would reduce the score if clicked on accidentally would involve using the variable and changing the score by -1. So that's sort of adding in a bit more challenge again. So over the years, I've created loads of sort of different projects sort of with different levels of difficulty to use with the children that I've been working with. I've dumped them all in a studio. They're a bit silly, quite a lot of them, because that's how I entertained myself. But if they're any use to you, the studio's there. Feel free to use them. There are all sorts of things. A lot of it is just where I was trying to test how to make something happen, like how to make the eyes follow another sprite and that kind of thing. So those are there if you want to use them, or if you want to give them to your pupils to pull apart and mess about with, then please feel free. Another strategy for sort of making sure that all learners progress through the lesson is helping them to become more independent. So one of the things that I used to do is to create little video guides or video snippets of things that I kind of anticipated that I knew they'd find tricky. So you'll find those in the FAQ. Those are all there on that Padlet page there. So things like I've lost my code. I always say when I'm doing any training around Scratch, I can guarantee that at some point a child is going to come to you and say, I have lost my code, and it's because they've clicked on the stage and not the sprite. How can I stop my sprite from turning upside down? And you can just do like little screen records, especially if you're using Padlet. That's really, really easy. Even the free version allows you to do this. You can add posts and then just do a screen record from within Padlet. So when you're preparing any of your lessons around scratch, then you can just do, anticipate what they're going to struggle with and do little screen records. But the ones that I found most commonly, I've stuck there in the FAQs column. The Teach Computing curriculum has lots of sort of short videos to show some of the technical skills, and they've been produced to help the teachers with some of those technical skills. But if you make those available to the pupils, then it means that if they've got access to those during a lesson, that if they've forgotten what they've been taught, they can always go back and watch those to help them. So it just sort of helps them to be a bit more independent. And then the final thing that I used to do, which worked really well mostly, were the FAQs whiteboard. So we had a whiteboard at the front of the class. This comes from the Lazy Teacher's Handbook, which was a brilliant book, FAQ boards. So at this point, the pupil would ask for help with something, and then I'd go and show them. I wouldn't show them how to do it, but I'd sort of help them through thinking about how to solve that for themselves. And then I'd put that as an FAQ up on the whiteboard, and they would put their initial underneath it or their name underneath it. And then when the next pupil comes along and they've got that issue, they can see and go to the pupil whose name is underneath the FAQ on the board. And then that pupil has got to explain it in the same way as I did, so that they didn't kind of give them the answers, but help them to work through until they came up with a solution. And then it goes on, and then that pupil adds their name underneath. And then you can also, as you're going around the classroom, if you identify anybody who's good at sort of helping with one of those FAQs, you can get them to add their name underneath as well. And it did work really well. It did make the classroom quite buzzy, and pupils would just be quite independent and helping each other, and they were always desperate to get their name up on the board. So you then ended up having to manage the queuing down the side of the classroom, where they'd be queuing up to put their name underneath an FAQ. So there are sort of management issues around it, but as long as you're aware of those and you kind of change the rules almost to make it work well, it does work really, really well. It did help a lot in the classroom. That you didn't have people waiting for you to come and help them, but also because they were really determined that they were going to work out some of the solutions for themselves, so that they can stick their name up on the board. I also tried it on a Padlet, which sort of worked sometimes, so that we had a Padlet FAQ board. So it was like the whiteboard really, but it was like an FAQ page online. I did find that one set of girls had used the opportunity to arrange who they were going to play with at lunchtime and what they were going to play, and so didn't come to that until the end of the lesson, and then read that and thought, right, okay. But it did work for some of the others who did sort of post their sort of questions, and the other children enjoyed responding to them. So if you're familiar with Padlet, one of the things that you can do is to turn comments on. So you'd need to do that so that one child could post their question, and then another child could post their comment underneath, or you as a teacher could. It means you don't have to leave your desk. And they could also add screen recordings to a Padlet wall as well, and that was just a screenshot of how you go about doing that. And that's it. Thank you.
Brilliant. Thank you so much, Sarah. That's great. Thank you.
You'd gone.
Yeah, well, I thought I'd gone as well. I was like struggling to click the right button. It took me a while to come in. It's the suspense. So I was trying to sort of make it a high impact return. Yeah, just got one question for you all, really. Quite a simple question, which is someone's just asked if it's possible to get hold of your slides. So if this does go up on the CAS sort of YouTube video channel, so you can access these after the session. However, if you want access to the slides, Sarah, Matt, and Ben, if you're happy to just like ping them to myself or thereafter, we can also get them sent out separately. Other than that, I've got no other questions. I'm just keeping an eye on the question window. But I think you've answered everything. I think you've given us all so much to think about. I think there might be a load more questions going forward. So I just want to thank Ben, Matt, and Sarah again for that massively insightful session. I think there's just lots of great classroom examples, and that's what I love. I love seeing all of those, you know, actual work in a classroom and those ideas of how to develop and how to really focus on that progression in Scratch. That's absolutely brilliant. As I said previously, this is the last CAS Inspire session of the series. And if you're on half term, well, thank you for joining and putting that extra time. If you're on half term next week, have a wonderful half term next week. So from myself and everyone here, and Leah as well, we wish you a wonderful rest of the day and a wonderful evening. Thanks, everyone.